So I would like some help with concepts and problems for the upcoming test.
Okay.
Um, yeah, I have done some review on my own, but I don't think it's sufficient for the test, and
Hmm.
especially for working out some of the problems. I have gaps that I would like help filling. Um,
No problem. Do you have any specific problems that are have given you a problem? Because that's normally the easiest way to address it. I mean, rather than just me, spouting off a bunch of principles and concepts or whatever.
yeah, so I will, let's see, I'll go on and pull up the ones that I've taken, and the scores on these are very poor because
That's fine. I mean, that's the whole purpose of those practice tests. Until you can consistently get like an 80 or higher on them, then you need to keep doing them. So it's perfectly fine and normal for you to get, even 20s, much less, a 60 or something.
yeah, this one that I took just before joining,
I think you might be able
I'm
to share the screen
disappointed
with
in
me.
the score. So let me go on and share my screen here.
No
Mhm.
problem.
Oh no, where's the tab? Okay. So this is practice test number one. I definitely need a lot more. The conceptual ones, can you see this all right?
I can, yes.
Okay. So I seem to get those down pat. I'll definitely review them more. This problem, this is one from like one of our last sections, isn't it?
Yes. Yeah, that looks like something that could be from chapter two, for instance.
And so with this one, I'm sure, let's see. Let me find my notes here. I looked at this and um
Yes.
I attempted to get the answer two different ways, but both of those options are not listed there.
Gotcha. It says at time t equals 0 seconds, a car is traveling along a straight line at a speed of 20 meters per second with constant acceleration. The car travels 56.0 meters during the time interval between 2 seconds and 4 seconds. What is the acceleration of the car? Okay. So what you have there is some information. Specifically, you've got a distance traveled.
Hmm.
At t equals 0, we can say v0 is 20 meters per second. We can say that from t equals 2 to t equals 4, x is the 56 meters. And you might even be able to do it with just that information, uh, possibly. So I'm thinking in terms of the equations where you have v final, uh, where you don't have a v final and a v initial specifically, because those are ones that don't necessarily, uh, that we haven't been given the key stuff. So I'm thinking the x equals 1/2 at squared plus v0t one.
Okay.
Yeah, you can set that equal to 56 meters, but you'd have to do x at t equals 2 seconds subtracted from x at t equals 4 seconds.
Oh,
You see what I'm saying? Because they did give you that nice piece of information that it was 20 meters per second at t equals 0 seconds. So that is your v0. And now you just need to solve for A if you did that. Let me show you on a uh I'll steer your screen real quick and I'll share
okay.
my screen with you. I might need you to refresh my memory on the numbers, but I think I know I'll remember them enough when I get back.
Okay.
So the screen should come up any minute now. There you go. So what we had is t equals 0 implied v equals v0 equals 20. meters per second. We also have x of t equal 4.00 seconds minus x of t equal 2.00 seconds is equal to 56.0 meters. I think it was just two sig figs though, wasn't it? 56 flat.
Um, yeah, 56.0.
And did it say that 56.0 was the displacement, or did it say it was the distance traveled, or what?
It says that that is the distance traveled during the time interval from t equals 2 seconds and t equals 4 seconds. So that would be displacement, wouldn't it? Between
Yeah.
in that
Yeah,
interval.
that's why I was being careful because I did do the displacement. Sometimes the displacement's different from the distance traveled. Uh,
Mm-hmm.
so I was sort of checking for that. But in this case, it seems to be one dimensional, so there really isn't any option too much of doing it unless the the critical point of the quadratic equation, that's the x of t, if that is such that it had a hump in between t equals 2 and t equals 4 seconds, then that actually might have suggested a problem. But what we can do is taking that last equation I wrote, x of t should be equal to 1 half a t squared plus v0 t plus x zero, which for all intents and purposes, there's almost never there's almost always an ability to set the x zero equal to zero. So we're going to do that.
Okay.
What I'll now do is take this equation, the one that I just circled, and I'm going to fill that in. So I'll say one. Whoops, I'll write in pen instead of laser marker. I'll say
It's
one half
attention
a.
grabbing.
Exactly. One half a 4.00 seconds squared plus 20.0 meters per second times 4.00 seconds minus, now I'm going to put this in parentheses because you got to be careful when you're subtracting something to make sure you distribute it. So I'm putting it in a bracket for that reason. So I'm
Okay.
going to say this is minus one half a 2.00 seconds squared plus 20.0 meters per second times 2.00. It's really having a hard time showing that decimal there. And then I'll put this and say it's equal to 56.0 meters. Again, I'm going with more sig figs than are really reasonable. But you can see that the 4 squared is 16 times 2. It gives me 8 A. We'll ignore the units for right now because it looks like all the units should work out. So I got 8A plus 80.0. Of course, that turns out to be meters, just plain meters again, as does the 8A. And then I
Mhm.
have minus 2 squared would be 4. 4 divided by 2 is 2. So this would be minus 2A. And then the minus has to hit this 20 times 2, so it'd be minus 40.0. And then all that is equal to 56.0. Well, I've been leaving the units off, so I really shouldn't have put that unit on there, so I'll leave it be. Now you can see it's a fairly straightforward equation to solve. I've got 6a is equal to 56.0. Now, when I do 80 minus 40, that gives me 40, but I'll pull it to the other side. So I'll say minus 40.0. That gives me 6a is equal to 16.0. Dividing both sides by 6, that gives me a is equal to, we know that a goes into 12, or excuse me, that 6 goes into 12, and that would be 4 left over. It goes into 12 3 times, so that'd be 3. And then, of course, we have 4/6 left, which is the same thing as 2/3. So it should be 3.667 meters per second every second. Was that one of the options they had, like a 3.77 or 3.67?
3 point.
3.7.
No, the options were 2.67, so it might be.
Oh, excuse me. No, that's right. It's 2.67, not 3 point. I was doing the arithmetic in my head, and you know how dangerous that is with me.
I
16,
need to get to that level
16
though.
is 16 twice, not 3 times.
Okay, so Okay, so right. Okay, I see. And then okay,
That makes sense.
and just to kind of clarify, so with this problem, we don't go straight to like plugging numbers into one of the kinematic equations because we're given those two different values for t.
Yeah, we're not really given enough. I mean, in some sense, you can go ahead and fill out the x of t equals 1/2 at squared plus v zero t, but you're not given
Mhm.
a. You don't have a specific time necessarily. But because they did tell us the distance traveled in a period of time, you know that period of time, the distance was x of 4 seconds minus x of 2 seconds. So you just find an equation for x that involves acceleration and an initial velocity not being zero. So that made me think of the 1/2 at squared equation.
Okay.
So when I did that, then I just had to do that equation evaluated at t equal 4 seconds minus that equation evaluated at 2 seconds. And that should give me a result of 56 meters from the problem. Notice the big thing was putting those brackets around the x of 2 seconds, because if you didn't do that, that would be a very easy way to make a boo-boo because you'd forget to distribute the negative.
Okay. When I had did this myself, I got the right formula, but I did it
Mhm.
wrong. I didn't do like two uh like plug t in for one the equation minus t
Mhm.
in the t equals 2 seconds. So that is where I messed up. I'm also going to take a picture
Gotcha.
really
Yeah,
quick.
and that was actually one of those questions that's got a lot of words in it. It's really easy
Mhm.
to get confused to what's actually going on. So like I had to read it 3 times myself just because when I first started, I was paying attention to something I was working on the computer over here. So I actually had to go back and read it a couple times before I was able to make sense. So it's perfectly normal that sometimes you just miss sort of the big picture and don't know what equation to apply specifically because you don't necessarily understand the problem. And sometimes you don't really understand the problem until after it's solved.
Hmm.
So that's pretty normal. A lot of times it's just a matter of taking a hope and a poke at what equation should be used, plugging it in, see if you get the right answer, and then thinking about, well, did I apply it the proper way? Maybe since I got the wrong answer, maybe I neglected something. That's where I came up with the subtracting of the two x of t's. And I
Okay.
haven't called them X of T before, by the way. So if that seems foreign, then that's certainly reasonable for it to seem foreign. But remember, that's really if you solve for X, that is technically X as a function of T. So same thing for Y. Y could be a function of T or a function of X, that kind of thing. So you can think of it that way as well.
And one last question about this problem.
Hmm.
So my me trying to figure out what equation to use and like how to approach it.
Hmm.
Um, I had initially, let's see, because I saw that there is displacement. So I originally used like the v squared equals like v initial
Right.
plus 2a.
That was the same thing I was thinking of when I first said it. So yeah, I get you.
But my mistake was I was like, well, I have one velocity. I can solve for the other velocity and try to plug it in. And um, so I went and did like v equals delta, or like the displacement over time, like
Hmm.
delta t. Got that velocity, plugged it in, and then tried to solve for it. So that gave me something that wasn't even an option.
Well,
So
actually, you could. I mean, there is a way you could do that. It would probably be a little bit more work. You could
mhm.
use the fact that the initial velocity was 20 meters per second, and you could say that the final velocity at t equals 2 seconds is something you don't know, but you just set it up and say this is the final velocity, uh, which is equal squared is equal to the 20 squared plus 2 times a times. In this case, you wouldn't know how much distance was traveled in the first 2 seconds, so you just have to leave it as x. But when you write it again for the t equal 4 second interval, you have another v final squared equals v initial squared plus 2a. This time it would be x plus 56 meters. So in principle, you could do it that way. Let me show you what I'm talking about. Just so you'll know that in many cases, other ways that you come up with, even if you got the wrong answer, it might have just been you didn't work it out fully. So if you're
Mhm.
thinking about using v squared equals v0 squared plus 2ax minus x0, as I told you, there's almost no chances for you to not be allowed to put x0 equal to 0. So what I do is say at t equals 2.00 seconds, we've got v squared equals 20 squared plus 2 times a times x. And then at t equal 4.00 seconds, we've got V4. I should probably label this one V2 just because that was at 2 seconds. So I'll put a 2 subscript on it. So this one I get V4 squared is equal to 20 squared plus 2a 56 plus x, like that. And now what you see is that you could, in principle, relate these two to find, for instance, the final velocity or to find the x. And that's or actually in this case, if you subtracted the two, you would actually be able to eliminate the x. And then what you probably need to do is use something like v bar, since it's constant acceleration, is v0 plus v1 over 2. You could use something like that to get the final velocity. You can plug that in those sides. That ultimately might work out, but you can see it's an ugly mess because I've got two
Mhm.
equations so far with two unknowns, actually with three unknowns, and I'm still figuring out a way to solve it. So don't get discouraged if you think of the wrong equation. It might just be you haven't yet figured out the way to apply that equation. It might still work. The only thing these equations are not valid in is when the acceleration is not a constant. I mean, they're even valid when the acceleration is zero, because if you put in a equals 0 and that x of t that I wrote, you just get v0t, which is the definition of basically how far an object goes with a constant velocity v0 in a time t. So it don't like I said, don't get discouraged if you choose the wrong equation, because it's often not the wrong equation. It's just an equation that needs a lot more work to apply it.
Okay.
Okay.
Yeah, I'm definitely not going with that second one. I'll stick with the first one.
I thought I
Yeah.
had a picture in my head when I started writing it, and then I ran into another headwind, and said, "Well, maybe not."
Yeah. Okay. So I'll keep that in mind. I need to plug in T for both T's and then solve instead of just
Exactly.
trying to do it all in one fell swoop. Um, I will go on and let's see. How long do we have, Professor Younger? Is it about an
I
hour,
I'll
just
put
under an
in
hour?
for an hour, but you just tell me, and like I said, if I get too busy or I have to do something, then I'll just call it off. But we can work until you know get the help that you need, anyways.
Okay. Let's see. I'll go on and reshare here for the second one. Okay. These last two, I need more practice on these problems. I will admit. So in the time before our session, I was looking at how to solve it, and then I ran out of time.
Right. So you did you put another one up yet? Let's see.
Oh, I did. Yes.
Let me I share and then look at your. Okay. This is number 5.
Yes, number five.
So that one I know for a fact there's a version of it floating around where it's asking you for the normal force. I haven't yet worked that out. So you can be assured that will not be on the test. I just know there was a little bit of a problem, and I gotta do a little bit of work to find the question, write it down, then solve it. But this would be pretty straightforward. It says a
Okay.
6 kilogram car is going around a curve with a radius of 120 meters that is banked at an angle of 20 degrees with a speed of 24.5 meters per second. What is the minimum coefficient of static friction required for the car not to skid? So with this one, what I'm going to do is immediately write down, and this is part of the problem solving stuff that you want to work on. So when I read that question, I immediately want to write m equals 600. And just to make sure we're on the same page, I'm going to write that as 600 period zero with an underscore on it so that I'm claiming right now that I'm going to say 600 is 3 sig figs. Okay. Uh,
Hmm.
I also say that the radius of the curve is 120 meters. And I'm going to again put a zero underbar after the decimal place so I can assume that one's 3 sig figs. The angle theta is going to be 20 degrees, and the velocity will be 24.5 meters per second. Since it's in meters per second, we know we don't have to convert anything. Also, the mass is in kilograms, so we don't have to convert anything. But what we're going to have to do is draw a figure to figure out what we're talking about here. So I'm going to say this is our bank. This is 20 degrees. Ignore this for a second, but that block is basically going to be the car. Okay. The
Do I need to
car,
stop sharing?
what's that now? Oh, I'm
Do
not
I need to
sharing.
stop
You might.
sharing? Stop sharing that.
Yeah, it was me. I completely forgot that I wasn't still sharing. There you go. It comes up.
Yeah, it's still loading, I think.
Yeah, take a little while.
There we go. All right, I see it.
Okay.
Okay. So
So
okay.
600 times 9.8, I'm just going to write that out as 5880. So this is 5,880 newtons is mg. Okay. Now, the weird thing though, when you're doing an inclined plane for a bank curve, this is one of the few instances where it's not good to change the coordinate system to a banked coordinate system or a tilted coordinate system. We're going to keep our coordinate system vertical and horizontal. So I'm going to say this is my x-axis, this is my y-axis, and so on and so forth. But in addition to that, of course, we know that we have a force that I'm going to draw as black as if it's not yet fixed to the components that are parallel to the axes. So this is going to be our normal force that's actually acting
Mhm.
on the car. Uh, Now, what we know is I'm going to say that that MG is pointing down. So I'm actually going to change its color from blue to red because I normally treat like red as like a stoplight as the negative and then maybe the green as a positive. So I'm going to say that this right here is the component of the normal force that is vertical. And then there's going to be a horizontal component of the normal force. So this is F normal sub H, and this is F normal sub V, like that. And of course, you might not be able to see it immediately, but this being 20 means this is 20. And
Mhm.
then this would be 90 minus 20. And then this would be 20 degrees again. So you can see that F normal sub H would be F normal times the sine of 20 degrees, and F normal sub V would be F normal times cosine 20 degrees. So we've got that. Now we also need an acceleration in the horizontal direction, like this. And that acceleration, A, must have a magnitude equal to V squared over R, which is 24.5 meters per second squared over 120 meters. And that gives me 5.002 meters per second every second. So that's obviously at least one extra sig fig. Now, if we find that this normal force is sufficient to supply that, then we don't even need a static coefficient of friction, but we should check what it is. What we do know is the summation of the forces in the y direction is equal to mass times acceleration in the y direction, but we don't expect the car to do any vertical acceleration whatsoever. So we're just going to put we're just going to call that zero. So then what you get is F normal times cosine 20 degrees minus 5,880 newtons. Now I'm working it right now as if there's no friction force. I have to redo this if there turns out to be a friction force, and I'm assuming there's going to be one. So I might not even want to waste my time. But was one of the answers zero on that? I didn't even look.
Mm, no.
Okay,
Yeah.
so one of the answers
I
wasn't
think it was
zero.
zero.
So since it's not zero, what I am going to do is say there's another force acting, and that will be the friction force. And that friction force, therefore, will be at that 20 degrees down the incline. So I'm going to say, let me choose another black pencil. Okay. I'm going to say this is our friction force, F, which should be equal to mu static times F normal. Okay. But we still have to have a breaking down of it into components parallel to the various axes. So the downward component is definitely a negative y component. And then there's a rightward component that is assisting in providing a centripetal acceleration. And again, this is also 20 degrees. So I can say the friction force is equal to mu static, and this is the max really, mu static times F normal. But I can also say that F friction in the x direction is mu static Fn times cosine 20 degrees. And I can say Fy is equal to, in this case, it's actually negative. So I'm going to force that negative in there and I'm going to say mu substatic Fn times the sine of 20 degrees. Okay. So now that I've done, go ahead. Were you getting ready
Sorry
to
to
say?
interrupt. So like the setup part is really like what I need to zero in on. So
Okay.
I just want to kind of like restate some of what you said just to make sure I'm understanding. So for and I read this in the book before joining as well. Um so the normal force is like the vector, it's like in between the y and the x axes.
Yeah, because it's got to be normal to, it's got to be perpendicular to the road surface, which is tilted. But yes.
Okay. So it's perpendicular to the surface. And we said the kind of like the x component of that normal force, that
Mhm.
is what is equal to normal force times the sine of 20 degrees.
Yes,
And then the y component would be normal force cosine of 20 degrees.
exactly.
Okay. And then that the x or the x component of the normal force is set equal to, or isn't that equal to the centripetal acceleration?
That is helping. So when I write the summation of the forces in the x direction, which I haven't written
Mhm.
yet, that will be one of the forces that's helping us make the car turn because the actual acceleration has to be parallel to that x-axis and pointing in the to the right because that's
So,
where centripetal acceleration should act.
so you went ahead and calculated that centripetal acceleration to use later in the problem?
Exactly, just because I knew that had to be a necessity because they wanted it going 24.5 meters per second and they wanted the radius of the curve to be 120 meters. So I knew I could calculate that.
Okay. And then
Okay.
for the summation of the forces in the y direction, you said, acceleration upward we're not concerned with and it's zero.
Right.
So you just put the normal
Everything that's
force.
got a casting a shadow on the x-axis has to be, or excuse me, in this case, on the vertical y-axis
Mhm.
has to be put on there.
Okay.
So then cosine 20. That was a positive one. It's pointing up. That's why I left it positive. The mg, which is 5880, that's pointing down. So I made that negative. And
Mhm.
then notice I did add the negative f sub y where that's your friction force.
Okay. because it's pointing down, so it's gonna lessen the normal force even more
Exactly.
with gravity. Okay. All right. I think I'm caught up now. What you were doing next is calculating the friction forces.
Yeah, so I've got the summation of forces in the y direction because I can't calculate a friction force until I know the normal force. And the normal force normally comes from the summation of forces in the y direction. So in this one, you can see, for instance, that the normal force, if I wish to solve for it, the normal force would have to be F sub y plus 5,880 newtons. And then all of that will be divided by cosine 20 degrees. Okay. I can also, of course, substitute what F sub y is. So Fn could also become F sub y, which we said was, I've already accounted for it being negative. So I'm just going to take the magnitude here. It's going to be mu static times F normal times the sine of 20 degrees plus 5,880 newtons, and then all of that will be divided by cosine 20 degrees. You see that we've automatically added in yet another F normal force. So we've got to take this and solve for the normal force anyways.
Mhm.
So if I did this, I could go ahead and write Fn. Let's do Fn. Yeah, I'll just break it up as a separate fraction. I'm going to say Fn is equal to mu s over cosine 20 degrees times sine 20 degrees times Fn. So that's the first term of that fraction, mu s times 20 over cosine 20, and then plus 5880 newtons over cosine 20 degrees. And now I can take this term right here and bring it to the left-hand side. So now I'm going to have Fn times 1 minus mu s. Might as well write this mu s tangent. So I'm just going to write that as mu s times the tangent of 20, because sine over cosine is 20 degrees, of course. And that is basically that first term that was on the right, or excuse me, was on the left on the right-hand side. That's what that minus part became over here. And then on the right-hand side, now all we have left is 5880 divided by cosine 20. I'm in degree mode, so that works fine. And this gives me 6,257.3 newtons. Obviously, that's two extra non-sig figs. So I can now say that the normal force should be equal to 6,257.3 newtons divided by 1 plus mu sub s times tangent 20. Now, that's all well and good, but we're actually trying to solve for mu sub s, right? We're wanting to
Mhm.
figure out what the static coefficient of friction must be in order, or did it ask for the friction force? I think it just asked for the static coefficient, right?
It was, yeah, what is the minimum coefficient of static friction required for the car not to skid?
So mu sub s min is equal to question mark. That's what we're looking for. So now that I have that, I can now use my summation of forces in the x direction. So the summation of the forces in the x direction is equal to mass times acceleration in the x direction. This is the acceleration that centripetal that we actually need. And the forces in the x direction, of course, are Fn times the sine of 20. I should go ahead and just make what the sine of 20 is, and that's 0.3420. So I'm going to say Fn times 0.3420. That's my sine 20. So that's the FNH. I also have the friction force times the cosine of 20. And cosine of 20 is 0.9396. So I'm going to say plus the friction force, which I'll say is mu static Fn times 0.9397. That gives me 4 sig figs, which is more than enough. The main thing is I want to always carry at least one extra sig fig. So that's two of the forces acting in the x direction, and that seems to be all of them. I don't see any more. Yeah, that should be it. And that all has to equal 600 kilograms times 5.002 meters per second every second, like that.
Professor,
Yes.
so in this step that you just did,
Hmm.
you see that you have the normal force, and we're talking about the x direction, so that's using the cosine of 20.
Uh-huh.
And then what are you adding to it? The friction force?
So, yeah, if we're looking, just to remind you, what I'm making use of is this force right here is in the x direction, and
Mhm.
that is Fn sine 20, and that's sine 20.
Oh,
So
okay.
this is
Sine 20.
that one.
Okay.
Okay.
Sine 20. Uh-huh. And then the second part, could you
This
restate what that
one,
was again?
yeah, so we're assuming that the static friction is doing the most it can, and that happens when the static friction force is mu static times the normal force, like that.
Hmm.
So that's why I have that there. That's my normal force. But now I need to multiply it by cosine so I can get that little component right there. So this is the cosine 20 times the friction. So that's that force. And those are the only two forces we see acting in the x direction at all.
Okay, so this is okay, so this is what you do when you have the added component of friction that you're trying to account for.
Exactly. And we have an expression for Fn, which includes mu sub s. So we can certainly, ooh, that tangent 20 is supposed to be on top. No, that tangent 20 is right there. So for instance, we can evaluate that tangent 20, and that will make that a little nicer, maybe. We can say 6257.3 divided by, actually, I don't need that part at all. I just need tangent 20. So that gives me 0.363. That's C63 or 3640 actually. So that's what the tangent 20 is. So now I can actually plug in these normal forces and say 6257.3 newtons divided by 1 plus mu s times 0.3640 times 0.3420 right there. So what I just did was recopy this with this plugged in for F normal.
Okay.
And now I'm going to do the same thing with this. So I'm going to say plus mu sub s times 6257.3 newtons times 0.9397. Now, all of that has to be over what we found for the normal force. So that's going to be 1 plus mu sub s times 0.3640. And all that, of course, is equal to essentially 5 times 6 would be, or 5 times 600 would essentially be 3,000. And that's newtons. So that should be sufficient right there. Now what we got to do is figure out some way to solve for mu sub s. Luckily, that 1 plus mu sub s times 0.364 is on the bottom of both terms. So what I'm going to do is multiply both sides by 1 plus mu s times 0.3640. And what that's going to do is give me 6 0.257.3 newtons times 0.3420 plus mu sub s times, I'm going to go ahead and do this math, 6257.3 times 0.9397. That gives me 5879. And actually, that's 5880, actually. So if I round it properly, it's 5880.0. That's the whole numerator. I can actually go ahead and do this 6257.3 times 0.3420. I'm going to erase that first two terms that are being that first term that's being multiplied. You see the two factors? I'm going to erase that and just put what that answer is. So instead of writing 6257.3 times 0.3420, I'm
Okay.
just replace that with the number 2139 or
Okay.
2140. Oops. Do you understand what I did there?
Yeah, so see, the only thing that I have a question about is actually what
Hmm.
you set the where you got the like the 600 and then the 5.002. The 5.002, where is that A of acceleration and the X direction coming from again?
Okay. Uh, that's what I did when I calculated v squared over r right
Oh,
there.
okay. Yes, I see it.
That makes sense.
Yeah.
So now I've got it reduced to some extent. All I have to do is get these two mu s terms on the same side of the equation. I see that the coefficient is quite big over here on the left, so I'm going to pull the 1092 mu s to the right. So I get 5880 minus 1092 gives me 4788. Whoops, 4788. Uh, mu s. So that took care of this term and this term. That is all equal to 3000 minus 2140. That gives me 860. Therefore, mu sub s should be 860 divided by 4788. And that gives me 0.1796. Which is again way too many sig figs. But the main thing is you should probably have something like 0.18 or zero point 0.2 or something.
Okay, let me check. One. I had I have 0.12.
That was one of the choices, but not 0.17, huh? Or 18.
I do not see 0.18. I see a 0.48.
Okay.
So I have 0.36, 0.60,
Hmm.
0.24, and 0.48, and then 0.12.
Okay. So I might have made any sort of arithmetic errors in here. I could have also made an algebraic mistake. So let's double check our work. Uh, we did have this 20-degree angle. We did have this 120-meter turn and 24.5 meters per second and 600 kilograms. Our friction force, I would assume, is keeping it from launching, over the berm, over the actual incline that is the banked curve. So the friction force should be acting down along the curve. So I think that's fine. The x component should be, of course, a positive one, and the y component should be a negative one. So when I did the summation of forces in the x direction, I did get mu static times the normal force times the cosine of 20. So that checks that term. I also had the normal force times the sine of 20, so that gives me the 0.3420 term. And then I had the 600 kilograms times 5.002. That should be the MA. So that all works out. If I check the Y, I did get Fn times cosine 20 minus 5880 and then minus the friction force Y component, which should be mu static friction normal times the sine of 20. So did I forget to substitute that sign in for anything on that? I don't believe I did. That gave me my normal force. And okay, with that normal force right there, I then went to compute it a little bit more. So I did plug in mu static normal force times the sine of 20. So that works. Plus 5880, that works over cosine 20, that works. And then I did make it mu sub s sine 20 over cosine 20 times f normal. So that works. And then 5880 over cosine 20. So that gave me the 6257.3. So that works. And okay, so at that point, what I did was I'm trying to remember where this line came from. Oh, okay. So this is our friction force, and I can solve for the normal force.
Oh, is it that the it's supposed to be one minus
Yes. Oh, okay.
efficient friction?
Yeah, I did have one minus and I made it
Okay.
one plus, didn't I? Is that right though? Let me see where it was. I'm trying to remember where that came from. Uh, okay, so now I'm putting in the normal force. The normal force, putting that in there. Oh, okay. Yeah, it was supposed to be one minus because right here I subtracted this term on the right hand side. I
Mhm.
subtracted that from both sides. So that gave me Fn times one that was there. And then minus, when it comes over to the other side, it'll become minus mu s tangent 20. So that's where that came from. And then this was 6257.3. So that's where that came from. But yeah, exactly what happened here was it seems that I've transformed that into a plus instead of a minus. And that would not be good. So yes, I can go back and fix that. The way I fix it, let's double check now. I'm going to take this one plus and I'm going to make those minuses. So let
Okay.
me go in here and I'm going to erase that. And I'm going to put in red so we'll remember that we screwed up earlier. I'm going to put a minus, and I'm going to put a minus here as well. And I need a minus here as well. So hopefully that's our mistake. And then when I multiply through by 1 minus mu s 0.3640, then nothing happens on the left-hand side because all that's still worked out. But this guy right here, this plus sign has to become a
Mhm.
minus like that. Okay, so now when I add uh, when I get the mu s over on the left-hand side, I'm now adding 1092 instead of subtracting. So this 4778 is going to be something entirely different. I can erase that. And what it's going to be is 5880 plus 1092. So 5880 plus 1092. That gives me 6972. So, so now if I take 6972 and divide it by 860, or excuse me, divide 860 by it, that gives me 0.12, which was one of your answers.
Okay. That's what I got too.
Okay,
So
good.
one,
Good job.
two, three. Okay, sweet.
Yeah, I got 1, 2, 3, 5, or 3, 4.
Mm-hmm. Yep, one, two, three, four. Yep.
Okay.
All
So that
right.
should be the proper way of doing it. And that also
Okay.
tells me something I can get with regards to the other student that was having a hard time. I might be able to now tell them what the normal force is because I finally worked it. Questions on that one?
No questions. I'm just gonna review your notes on
Okay.
you, and then as I do more practice problems, try to apply that. This is more involved than I thought, so definitely need to practice that some more.
Yeah, these are the harder ones when you actually have to go back and do the derivations or part of the derivations by yourself. That can be a pain.
Mm-hmm. All right. Let's see. Do you have to go, Professor Younger?
Not yet, but thank you
Because
for concerning yourself.
what is it?
I said, but thank you for concerning yourself with that. It's good. I'm good right now.
I am. I'm a writing tutor at my school,
Oh,
so
gotcha.
I know how it is.
Yeah.
Yeah, when you get bombarded with questions and you have somewhere else to be. So, let's see. I just have one more question on this practice test.
Okay.
This is something from chapter 6. So, I'd say after that, even though I do have some other ones, I could probably apply some of the things that we learned, we discussed it to those.
Gotcha.
Let's see. I'll go on and share my screen again.
Okay, let me take mine off. I think I have to. There's probably a way where I can just, there you go. What is the radius of the orbit required for a satellite to revolve around about Uranus with the same period? Okay. So this is one of those problems where we are basically using, let me show you. Let me get these numbers real quick. 17.24 hours, that's the period of rotation. So I'm going to write T Jupiter is equal to 17.24 hours. I'm also going to say that the mass of Uranus is, is equal to 8.69.
There's no right way to say that. It's like it's either Uranus or it's Uranus. And either way, it doesn't sound good.
Doesn't sound that good, does it?
Yeah.
Okay. So, all right, let me steal the screen from you again, madam.
Okay. Stop sharing. And like I look at this and I know it's using the law of universal gravitation and with the um you said with the period, like I know that or at least at first thought, I'm like, well, there's probably like Kepler's third laws in there somehow too. It's
Yeah,
just with combining it, it I'm still lost.
right. So, you're everything you're thinking is right, and it's probably you're sort of handcuffed by your own self-doubt, not necessarily anything problematic, but what we're using is the summation of the forces is equal to mass times acceleration. And in this case, we're only talking about radially, so I don't have to do any y-axis. In fact, I can just treat it all as if it's radially pointing outward or inward from the center of Uranus. But the only force acting, of course, is Newton's gravitational force, which is G times the mass of Uranus times the mass of the satellite divided by the radius of the orbit squared. That's the only force acting on the satellite. Now, that also has to have the satellite having a centripetal acceleration that results in a geosynch or Uranus synchronous orbit. So I'm going to say the MA is M times V squared over R. That means immediately one of the R's can cancel out, but also that means V is 2 pi R, or the radius of the orbit, of course, or I should say little r, divided by the period t.
Okay.
So you can also see that the m's for the satellite cancels out, and I'm just left with, they asked for the actual height, yes, not the radius, or did they ask for the velocity?
Yeah, what is the radius of the orbit
Yeah.
required for the satellite to revolve around Uranus with the same period?
Okay. Now that I have all that, I can more or less convert this to Kepler's third law because I've got G M Uranus over R is equal to 4 pi squared R squared over T Jupiter squared. I just called it T earlier, but now I'm calling it T Jupiter. So now you can see that if I pull the R to the right by multiplying both sides by R, I'll get a 4 third, or I mean a 4 pi squared R cubed. So what I can do now is I can say G times the mass of Uranus divided by 4 pi squared. I think that should do it there. Actually, I made myself more of a fraction bar than I really needed. So I need to put the T Uranus. I said Jupiter. Oh, yeah, it should be Uranus anyways, but T there. I need to put that squared here and then 4 pi squared in the bottom, and that would leave me R cubed.
Oh, okay. Okay, so rearranging everything. So you isolate the R, and then you're gonna take the cube root
Yep, exactly.
on your thing.
So R should be equal to the cube root of 6.67 times 10 to the negative 11th. And that is Newton meters squared per kilogram squared times the mass of Uranus, which is 8.69. I don't know why I was saying Jupiter earlier, but I must have. Times 10 to the 25th. And then all of that has to be multiplied by, now here we're going to take 17.24 hours and multiply it by 1 hour is equal to 3,600 seconds. And then of course it's squared. So I got to put all that squared and then take the cube root of it. And then of course I have to divide by 4 pi squared.
Are we putting it in the seconds just because of the newtons, right? Because it's
Yeah,
kilograms per meters per second.
basically, whenever you use in any of the equations we have, we need them in their base unit, which includes kilograms for mass, but everything else should have no prefixes in it. And of course, the unit of time would be seconds. So I'm getting 6.67 times 10 to the negative 11th times 8.69 times 10 to the 25th times parenthesis 17.24 times 3,600. Now I'm going to square that. And now I'm going to divide all that by 4 times 3.14159. And of course, that pi is squared. So I get the cube root of 5.655 times 10 to the 23rd. I'm going to raise that to the 1/3 power, because that's the definition of what a third root is. So I get R is equal to 8.2696 times 10 to the 1, 2, 3, 4, 5, 6, 7 times 10 to the 7th meters. And that's the actual radius of the orbit. That's the distance from the center of Uranus out. If they're asking for the altitude, then you'd have to subtract Uranus's radius out, but they didn't give it to us, so I'm thinking they're actually asking for the radius of the orbit, and that should be 8.27 times 10 to the seventh.
So it's just the radius of the orbit of let's see, oh, the satellite revolving around the planet Uranus.
Exactly.
Now to radius, the same period. So how would I know what the radius of Uranus is?
What's it asking you for, the altitude, or is it asking you for for the radius of the orbit?
Oh, it's only asking for the radius of the orbit. But
Right.
if I did have to find the altitude,
Yeah,
how how would I
we
find
would
that
have to give
radius?
it to you. We'd have to give you the radius of units, and that's not like in the
Oh,
front cover of my books. It'd be something that probably has to speak for it. So you probably have a glaring time, but that is the number one most often mistake when people calculate this. They'll ask for the altitude of the satellite, which means you got to that radius of the planet's radius. But that's the most common mistake students make when doing this. They all this right, but then they forget to subtract out the planet. In this case, we're lucky because they asked for the altitude, asked for the orbit. So you but keep that
okay.
in mind. Like, if you're asked to do it like this, write down a note to yourself. They ask for the radius of the orbit, or are they asking for the altitude. If they're asking for the altitude, you subtract out the radius of the planet.
Okay. Which you said they give your audio was cutting out a little bit. It might be my internet.
No, I'm actually having to use the audio from my cell phone for some godly reason. Right now, I can't do anything as far as audio goes. I had to use the phone. Uh, yeah.
Yeah, I don't know why I did that. It started getting choppy. But from what I picked up was that they would provide the like radius of the planet,
Yeah.
which kind of makes sense because if that's something they have to calculate specifically, I guess. Let's see. Yeah, I want to respect your time, Professor Younger. Yeah, those are the questions I had so far from the practice test, and I'm also going to go back and try and review those chapter practice tests. Um, yeah, and see if I can't try to piece those together too. Was your answer? Oh, let me check. 6.27. Go back and look. I just closed it. So that. Yes, it was. Yep, the second choice. 8.27 times 10 to the seventh. Yep. Well, thank you again. Let's see. Oh yeah, no worries, no worries. I really appreciate you joining and at least helping me clarify a few things from the practice test. Okay, yes, thank you. Yeah, I probably have some. You have a good rest of your weekend.